Now while we finish this SVD and PCA, we'll go on to matrix factorization. Okay. So what is this matrix factorization? In the previous session, I even told you that there is something called as matrix composition. Composition. Composition means if you have, let's suppose, B and C, if you multiply them together, you compose two matrix. You compose this B and C to get, let's suppose, some A. So this is matrix composition. Then we have something called as matrix decomposition. So we have decomposition. Matrix decomposition. Decomposition means if you have a matrix A, you want to decompose it into some matrices. Let's suppose you decompose it into BC. So composition, decomposition have same thing in common. That is, the meaning basically is if you take this C and if you take this B, whatever the effect they produced, you for example multiplied a vector, let's suppose X, with C and then with B, so you got some A. So that basically means if you take this B, C and you multiply the X, you will get the same effect if you multiply this A onto X. Similarly onto the same thing is over here. So meaning basically is what if we have a number of transformations, whatever they were trying to do individually, and then what was the combined effect of these transformations. So if we have a single matrix like this A, so A here produced the effect that is produced by B and C combined. So similarly into this decomposition. So that's the meaning of factorization, or decomposition is also known as factorization. We try to factorize it. Okay. Now let me give you a real world example first. Real world example. Real world example in terms of recommendation systems. Okay. Recommendation systems. I would like to teach you these things in detail, but here I'll first motivate these things so that you get to know where are these factorization used. So now you know the factorization. Factorization basically means if you have a matrix and you decompose it into certain matrices. Okay, so what is the real in this recommendation system? So if you see the problem at hand that we have is to predict ratings, to predict, let's suppose, ratings or recommend some items, because first we'll be predicting ratings, then we'll be giving the recommendation. So if the rating is, let's suppose, greater than some 3, so we'll recommend the videos out of 5, let's suppose, out of 5. Let me first show you how it is. Is everybody with me right now? This is really interesting example.
Yes, sir.
So let me see. Umar is here. Zubair, are you there? Rian.
Rian. Yes, sir.
Yes, sir.
So just look at this. Look at this. How problems are solved in real world. Like, first thing is, my goal here is to recommend some items. That is a problem that is there in the real world. Now see how I'll mathematically model it. That's my first step. My first step is to model the problem mathematically. So if I am able to do it mathematically, then I'll see, okay, what are the techniques that I can use to recommend the things. So now in the first step, let me tell you what there are. So I have set of items. Okay, I have a set of items. Let's suppose if we talk about Netflix, let's suppose we'll talk about Netflix or YouTube. So YouTube or Netflix. Okay, so I have set of items. So in terms of YouTube and Netflix, so we have movies. So let's suppose we have movie 1, movie 2, movie 3, and so on till, let's suppose, a movie 100. These are our set of items. Then we have set of users. Okay, let's suppose users are U1, U2, and so on. Let's suppose still some user, okay, something like this. So these are my things. So here in my real world problem, I have some items, for example videos, or in Amazon I have some products, and I have a set of users. Then some users, what they do, now we have two types of things. We take either explicit feedback or we take implicit feedback. So what is explicit feedback? Explicit feedback is if you buy an item, for example, or in the video when you try to interact, if you press the like button, if you comment something or something like that. So we can create a matrix out of this. We can create a matrix. So how I'll do it, I'll make a matrix like this. So in here, I'll say this is my user 1, this is my user 2, this is my user 3, user 4, user 5. Let's suppose I'll just make smaller matrix. Please focus here because it's really important, and this will teach you how to make a recommendation system. Not only that, this will also teach you how to take a problem that exists in real world and how to mathematically model it, and then how to use the techniques that you have studied so far. This is my movie 1, this is my movie 2, this is my movie 3, movie 4, movie 5, and movie 6. Okay, these are my movies, or these are my items which I'll call, and these are my users. There are two types of feedback. The first feedback is implicit or we have explicit feedback. Explicit feedback says that when the user explicitly interacts with it, it gives a rating to the item, or it comments on the item, or something like that. It does something to the item, and which is explicit. If you see in this movies, You go onto this IMDb and you rate it 9 star. If you go onto this Amazon, you rate some product as 5 star, something like this. That's called implicit rating. Explicit feedback means that implicit feedback means that you are not interacting, but our model is trying to figure out how much interested. There are some metrics there. For example, you are giving a lot of watch time to YouTube, and you are interacting at the same time with the YouTube. Now YouTube comes up with the metric so that it says how much is a video interesting to like this person. Okay, he sees the interest of the person into that video. If you comment on the video, if you like, that's why these people always say, please like the video. And there is something written in the description. Please see my comment section. I have pinned a comment. Why? Because they want to get engagement. Like, how many of you have heard YouTubers saying, I have pinned the comment, I have written something in the description? Why? Because if you interact with the video, you are giving this implicit feedback. So maybe you are not thinking that I am giving a feedback to the guy, but if you are interacting much with the YouTube, if you are trying to comment on something, so YouTube algorithm sees that there is a feedback, maybe this person is interested. Then when he scraps all of these comments and to see if the comment was positive, if it was negative, and then it ranks the video in terms of, okay, you have a user and you have this. And let's now first fix on explicit feedback, and because this is easier to understand. Let's suppose some of these items are, because it's impossible that every user will rate every item. So let's have some random ratings. 3, 2, 1, 0, 4, not even 0, let's suppose 1, 2, 5, 5, 6, 1. Some ratings will be there, and most of the ratings will be missed. Okay. Now what we try to do is we try to find similarity between the users. Okay, that's the first thing we try to do. We try to find similarity between these users. We try to see how much users are similar to each other. Okay, so let's suppose we'll write 5 over here, and let's suppose this is like this. Let me again to put some numbers so that I can show it clearly to you. Let me think a bit. So this is something like that. Some number, I put some random numbers. Now these are the items that haven't rated. For example, user 1 has only watched movie 1 and it has rated it. User 2 has watched these many movies, it has rated it. And user 5 has watched these many movies. So if you now see, so here if you see that user 2 and user 5 are more similar to each other. Okay, so why? Because they have watched this movie too, and both of them have given same ratings. Okay, now they have watched, let's suppose, let me change this rating to this is to the 5. Let's suppose we'll make them similar a bit, some 2 like this. So if you see here, so ratings are again similar. So if you see over here, so ratings are somewhat similar. It won't be exactly similar, but here I'm saying the case, the user 5 and user 2, if you see them, they're pretty much similar in that scenario. So they have for example, user 2 has watched certain movies, there's an overlap in watching the movies, and they somehow gave the same ratings. Now if I have to recommend some movies to U5, so here you saw that I am telling that this gives rating 1, so it will be in that range 1, because I am seeing that these users are some sort of similar users, or they have similarity between the watching pattern is similar. So I'll try, if I want to recommend this movie to something, so if this movie was rated 4, let's suppose, so then this guy has high tendency that it'll also rate it 4, because they are similar users. Okay, so I'll maybe recommend this movie 4 to this user 5 as well. Okay, so the assumption here is that similar users like similar content. So how is similarity defined? So there are a lot of things that we see in the similarity. So in this case, we are seeing similarity based on the feedback and based on the things they have seen. Okay, so that's what they have seen. So this, if you see it over here, so here I'll recommend this movie because this guy has gone 4 and these users are pretty much similar to each other. Okay, that means movie 4 can be recommended to this. Is it clear?
Yes, sir.
Yes, sir.
Okay, so now again in terms of the items, there will be similarity in the items as well. So let's suppose if there is an item which is similar to each other. Let's suppose we have this item. Let's see this M2 and this M6. They are somewhat similar. So if you see this user 2 and user 5, if you see this, the rating that they got, for example, 2 and 2, 1 and 2, something like this. Let's suppose this M1 item and M6 item is somewhat similar. So if somebody likes M1, there is a high tendency that M6 will also be liked by that person. So the first thing is similar users like the similar content is the assumption. So for the users who have the similarity score high, so we'll compute something similarity score and then we'll give them similar items. So again, if one item is seen by that user, and we'll try to give it the similarity which has, for example, if somebody watches this movie M2, if M6 is similar to that, we'll recommend an M6 movie as well. That's how I sort of mathematically modeled it in terms of a matrix. Okay, so this is how I have modeled it. So now I want to use the method of matrix factorization. Okay, because I have to predict these ratings. I have to predict these ratings. Okay, this is what I have to predict. There are a lot of ratings because I have been given a less rating. So what I'll do is I have this matrix A. Let's call this a user item matrix. Maybe you won't be able to find these terms somewhere. Whatever is coming to my mind, I'm naming them that. So this is my user. This is my matrix A. So you saw how I had a problem. I tried to model it with mathematics. This is my mathematical model of the problem. So now what I will do is I'll try to factorize this matrix into some matrix. Let's suppose VU and V. I'll call this U matrix and as user, and this I'll call as item matrix. Item matrix. So what is the meaning of this? So look over here. So now what I'll do is, so this is my user matrix. I have this user 1, user 2. How many users I had? So I had 5 users. So user 1, user 3, user 4, user 5. Okay. So then I'll make the matrix. I had item 1 M1. Let me write it like this: M1, M2, M3, M4, M5, and M6. Okay. This is what I have. Okay, so this is what I have. So now let's suppose if we take example of movie 1. Okay, so movie has different sort of features. So movie has a comedy component in it, movie has an action component in it, movie has some adventure component, maybe it is romance, it is some, like, let's suppose sci-fi, something. Okay, so movie has a lot of components in it, and user also has tendency towards that component. Okay, so user, let's suppose user U1. So user U1 maybe liking comedy, he might be this is action, this is adventure, and this is, let's suppose, some romance and some sci-fi. So what I'm telling you is that if movie 1 has, let's suppose, comedy factor of 1, let's suppose if here is the adventure, we are giving these numbers out of 10. Adventure, it's 9, and this is let's suppose 5. This is romance, it's 4. Sci-fi, it's 0. So this guy has a high tendency to watch action movies. Let's suppose he watches action movies 10 out of 10, and comedy movies, maybe he likes to watch comedy movies 5, and he doesn't like to watch sci-fi movie. Let's suppose he'll give a 1 number, and some 2, someone. So this is called a user profile. Okay, so one entry in this matrix is called a user profile. So now you saw that we made a profile of user. So here we had this comedy, we had this action, we had the adventure, we had this romance, we had this sci-fi. And similarly, if you see it over here, so we make the item profile. So this is the item profile. Item profile. Okay, so comedy, it contains 1 component of comedy, 9 components of action, 5, like it has very high action, it has moderate type adventure, it has moderate type, it is 0 sci-fi. There is nothing sci-fi in this. So what I'm telling you is that if you want to see if U1 will like this M1, you will perform the dot product of these vectors. You'll perform the multiplication of user profile and this. If this number comes out to be really high, if this number comes out to be, you recommend it. You'll recommend that thing. Because let's suppose 5 multiplied by 1 plus 10 multiplied by 9 plus 2 multiplied by 5, 1 multiplied by 4. So if this number comes to be, let's suppose 100, some 100 is a high number. So the weak number will be, let's suppose, the maximum that we can get is 10 square plus 10 square, because we are given 10 numbers. 10 square, how many times? 1, 2, 3, 4, and 5. So this will be 5 times of 10 square. So this is what we'll get. So we'll get 100, 500 will be the maximum score, and least score will be 0. So we'll be getting 0 to 500 score. So we'll be getting here 0 to 500. So if you perform the dot product of this U1 to this M1. So in order to see will U1 like the movie M1, so what I'll do is I'll perform the dot product of this U1 and M1 and compute the score. Let's suppose that score came out to be, suppose 350. So 350 is a good score. That is the rating of, like, out of 5 star, it is 3.5 ratings. So maybe I'll recommend that video to it. So are you seeing what I'm doing is I'm factorizing a matrix. So factorizing this matrix, and if you multiply this, let's call this user matrix U and this is V. So what I want to do is whatever matrix, item matrix I had, that A, I want it to be factored so that U multiplied V should be this. So if I have ratings over there, if I have, for example, let's suppose 5 ratings onto this. So here, so user 1 and M5. So user 1 and M5. If I perform dot product of these, so the multiplication should give me the value of 500. Okay, so what I'm saying is that I am breaking this matrix into 2 matrices, U and V, such that the breakage is done so that this matrix is approximated by these U and V. Is it clear?
Yes, sir.
So if it's approximated by this u and v, let's suppose we have this entry where u1 and m3. So if it got rating 5 in the original matrix, so when you perform this u1 multiple m3, it should also be nearly equal to 5. So that time I'll say that I have factorized this matrix really well. This u and v got really well factorized, so the ratings that I'm getting is this. So what I'll do is, so I'll have this u matrix, I'll have this v matrix, and I have this a matrix now. Some entries are there in a matrix. Okay, some entries are there. Again, to make it really good, so this is 3 4 5 1, something like this. 3 4, then nothing, 1 2 2 5, something like this. So what I'm doing is I am trying to factorize these two matrices so that this value should be 5. So this value is because of this and this. Okay, isn't it? Because of, let's suppose this is user and you last user, let's suppose un, and this is some last movie. So this should be 5. So I'll give these numbers in such a way and these numbers in such a way so that the product should be 5. Okay, and for this entry, so this entry basically is the output of taking, let's suppose this is some ij entry on in this a matrix. You take ith row of user matrix, dot product it with jth column of v matrix, you will get the rating. So you will have these values set in such a way so that you approximate these values, the values that are in their matrix. But obviously you will get all these values filled somehow, because let's suppose you'll randomly initialize these values first and then you adjust the value so that you get 5, or here you get 2, because multiplication of this and this should give you 5. You'll adjust these values. Okay, and similarly you will adjust, if you get 2, you'll adjust this value and this value, let's suppose. So when you're adjusting the values, other values are also getting adjusted. Now if you want this entry, so what you will do, if you want some entry, let's say a k, let's suppose q, so what you will do is you will now take kth row, you will take kth row of v, multiple dot product it with qth row of qth column, basically qth column of v, and you will get this rating now. This is how the problem was solved in Netflix challenge. This is the whole algorithm they used. They first constructed this user item matrix, then they factored it into two matrices, user matrix and item matrix, and then when you perform the multiplication, you get the other ratings as well. And if the rating is greater than 3 or something, and you will now the recommendation system are way sophisticated than this. I'm just giving a simple example right now. So now the recommendations are way sophisticated. They use reinforcement learning, they use deep learning and stuff like that. But this is the starting point. That's a good thing to motivation of this matrix factorization. Now you can factorize this matrix into many ways. Now we'll go into the methods. So first tell me, is this clear? Is this the recommendation, how this recommendation is built by using matrix is clear?
Yes, sir.
Okay, and this might be asked you a case study sometimes. For example, if somebody can ask you, how can you apply this matrix in terms in recommending systems? So there you can give an example. I just gave an example what came to my mind. And next time I will be reading recommendation, we'll deal these things in detail, and we'll see what are traditional methods, what are some deep learning methods, what are some reinforcement learning methods that they are using. So now I'll just note down all the factorization methods that we have seen so far, but I haven't given you the name. So I'll first write, if we have a matrix A and we have decomposed into LU, but you don't know where we have used that. See, if you remember your first, second, third lecture maybe. So in that we had a matrix A and we tried to reduce it into upper triangular matrix. Just raise your hand if you remember this. So we had the Gaussian elimination and there we tried to do this. Okay. So when you performed that, you basically were doing A and you were trying to reduce it to upper triangular matrix. And the operations that you are performing, you also can operate them in that you can collect them into elementary matrix, which we call E, and that will be lower triangular matrix. So the operator you'll be performing some operations, and that gave you U. Okay. If you collect this operation matrix as well, that will be L. Okay. The method of elimination that we used. So elimination basically gives you a factorization, LU factorization. Okay. Again, this is one of the factorization. A is equal to LU is one factorization. The other factorization that we saw is A is equal to QR. Why do we saw it? If you remember Gram-Smith, if you remember this, so what we try to do, if we have a matrix A, we try to find Q matrix. We try to find the set of orthogonal vectors, because we had some vectors in that which were non-orthogonal. We try to find a set of orthogonal vectors by using the Gram-Smith procedure. Okay, so whatever you perform the operations over there, if you collect them into again matrix, you will get a row reduced echelon matrix and the matrix. So this is n the factorization. So this factorization was because of elimination, and this factorization was because of Gram-Smith. And then we saw something, S is equal Q lambda Q transpose. Okay, what was this? This was our own diagonalization, I think. Diagonalization. But this was for symmetric matrices. Symmetric matrices. Actual diagonalization was S is equal, let's write that A lambda A inverse. Or even this A, let's suppose A, and we'll write S over here, and we'll write S inverse. So this was our diagonalization. Okay, and this was for the symmetric matrices. And then today we saw that A is equal to U sigma V transpose. This is our SVD. So how many methods are there? 1, 2, 3, 4, 5, I think. 5. So we saw 5 matrix factorization methods, and we haven't named them yet. But now you can name them clearly. So you saw that we have an LU decomposition, that this is called LU decomposition sometimes. We have a QR decomposition, that's from the Gram-Smith procedure. So if you now see diagonalization for the symmetric and non-symmetric matrices, you see this. If this is the symmetric matrix, this Q is an orthogonal matrix basically. So this is for the orthogonal matrix. That's why S and S inverse. So I can write it orthogonal here. Q is orthogonal. So then we saw diagonalization, or it's sometimes called a spectral theorem, and we saw SVDs as well. So this sort of ends the discussion on the matrix factorization. I also showed the case study where it's used. It's used in recommendation systems. Matrix factorization for recommendation system. Okay, and then we have seen the whole process, how we tried to mathematically model a problem. First we had a real world problem, tried to mathematically model it, and then when you have mathematical realm, you try to use the techniques that we have seen so far, and you can convert this user matrix will be, let's suppose L matrix, this will be U matrix, something like QR matrix, some matrices, so that it approximates this. Okay, and then we can also decompose matrix into multiple matrix, and you can now find research papers on this matrix factorization in recommendation systems. Try to find these things and see, can you understand these things? If you have any questions, I'm ready to take them. Otherwise, I'll stop recording over here.